Welcome, guys. Welcome, guys. So, before I start, hopefully subscribe to my channel. Okay. So, in the previous video, we proved this freshman string. Yeah, or in my previous video. Okay. So the freshman string, let me just recall that the freshman string is basically if you were like the freshman, or hopefully in the junior high school or something like that. You will say x plus y to n will equals this, right? But this is definitely not true if you choose n equals to 2. But in the commutative algebra, if you assume that the commutative ring with the characteristic p, or you working in the just FP field, then it's easy to prove that x plus put p equals to this, right? So now the freshman string come true if you working in some commutative algebra. But there's a thing called the sophomore strings. Actually, I didn't know this. I mean, yeah. But sophomore strings is very, very amazing that these two identities. So for example, this is 0, 1 divided by x to x dx, right? It's obviously that then this should not be the same as this from 1 to infinity, right? If you are very naive, then you will think they are the same, right? Yeah. Okay, but actually they are indeed the same. And also 0, 1 x to x dx will equals to this. So these are very, a little bit amazing. Okay. So now this video, I just want to provide detail, and I will go through step by step with you guys, and subscribe to my channel. Okay. And leave the comment below. Okay. So let's go back to let's prove these two identities. So one can first write down x to x to be exponential x log x, right? And use the so-called Taylor expansion. So you get n0 to infinity x log x to the power n divided by n factorial. So this is a Taylor expansion of exponential function. So now, if you don't know the advanced calculus, then it's fine. Yeah, you don't know uniform convergence, but it's fine. So if you don't know that, you can safely just exchange it with the sum of your integral. Okay. So now now the problem is that you only need to compute this 0, 1 x to the n log x and dx, right? So once you compute this, then you can exchange it with the sigma to an integral, and then you get the answer. Okay, so now the difficult thing is that we need to compute this stupid integral, right? So the idea is that x equals to minus u divided by n plus 1. So this is a change of variable. So dx is this guy. So you have chain rule, so minus du divided by n plus 1. Okay, so you put all in. Okay, so let's see the integrand. So when x equals 0, when x is 0, then u should be 0, right? So when x equals 0, u should be negative infinity. U should be infinity, because exponential negative infinity gives you 0, right? So infinity. And then when x equals to 1, then exponential 0 equals to 1, so 0. Okay, so and this is your xn. So there's n here, and the log x, what is log x, right? Take a log will give you the exponent to the power n, and the dx you need just put in dx in. Okay, amazingly, you just do a little bit algebra, then you get this, and then you get this. Well, minus n divided by n plus 1, n plus 1, 0 to infinity u1 exponential minus u du. And then this is so-called gamma function. So if you don't know gamma function, then I will give you the video link, so you can go to check out the gamma function if you don't know, or basically you see, so I will give you the gamma function lecture. I prepared 4 lecture about gamma function and their variance. Okay, so this integral finally become minus 1 to the power n divided by n plus 1 gamma n plus 1, so it's n factorial, right? So now the right hand side become from n to 0 to infinity 1 over n factorial, and this integral. And very happily that we already proved this integral is the same as this. So divide n factorial will cancel, then finally you get minus 1 to n plus 1 to n plus 1. So now I can change n to be 1, right? So I get the. So this is start from 0, right? But if I change it to be n to the n, then I can change it start from n equals to 1. So that's why this guy is true. Okay, so we prove this here. And what about if I change negative x here? So if I change negative x here, then all the proof is the same, right? It's especially when I do a Taylor expansion, there's an additional minus 1 to the power n, right? So this minus 1 to the power n will cancel this original guy, so we get this. So just cancel. Okay, that's it. So very happily we proved the sophomore string, and hopefully there will be not like I don't know. So what is the English in the second year? Who cares? Junior string. Okay, I will see you guys in the next videos.